In the past couple of weeks, I have been trying to build a custom computer on this board, a 𝚙𝚘𝚘𝚐𝚛𝚘𝚘𝚘𝚙𝚘𝚘 Nano 9K. A custom computer would mean a custom CPU design and a custom operating system. This is all inspired by a Git repository from 𝚙𝚘𝚘𝚘𝚐𝚛𝚘𝚘𝚎𝚛, the person who at 17 hacked iPhone and PS3.
This project is about fun and learning. It is about the journey, not the fucking destination.
Look at that! Look at that! Do you want to be reading bits and bytes? Do you want to be designing processors? Or do you want to be writing fucking websites? Do you want to be replaced by a robot? I want to write my own OS. I want to change the fucking world. You can be writing your own fucking compiler and you can see that it's fucking possible, motherfucker. If you don't understand how a CPU works, you're just a kid in the industry. You can't decide to do things. You cannot innovate. You can't be like, oh yeah, I designed this chip that works well with autonomous tractors working on farms and sell it for $1 gazillion. We're going big, bro. This is not child's play. Fuck the fucking front end and back end and Node.js shit. I am going to spend energy and time on it until I figure this shit out. Every fucking day I'll do the same thing every fucking day. I'll upload the same fucking video. Alright, bro. After hours and hours of coding, I wrote an assembler for RISC-V, bro. Look. I gave it this code, and it gave me this. It's in Python, and look, it's very short, it's not that much, but it works. Next step, I'm gonna write a RISC-V machine in Verilog that'll run the code. It's gonna be easy. It's gonna be nothing. No pipeline, no nothing, single cycle, super slow, with a SPI flash as memory. So let's see what happens. Knowledge test. If you know the answer to this question, you're not a normal programmer. What are the stages of a processor executing an instruction? 5 stages are fetch, decode and read reg, execution, memory, and then register write. If you named 3, we can say you're in the clear, but if you have no idea what these are, the processor is coming right up. I'm writing it tonight. Good morning. I am slowly losing sanity over this RISC-V computer that I've got good news too. Look, it runs, it reads registers, and I've, for a test, I've put numbers 3 and 2 in register 1 and 2. So that is the instruction. It's an add, and RS1 is 1, RS2 is 2, so 3 and 2. 3 and 2. Okay, so I put the code on here. It's supposedly sending a hello word through the UART, but what is that? I feel like it's communicating with Satan or something. Something's happening. Okay, I just want to go there and sit in front of the TV and work on this. So I connected this through this wire to my computer so I can load things on it. And I have my Linux running. I'm gonna go there in front of the TV and connect my MacBook through Wi-Fi, through an SSH connection to my computer, and load code through Wi-Fi, through this wire on here, and then read the results through these 2 wires into the computer through Wi-Fi and to my MacBook over there from a wireless connection. See, it's flashing my device from my MacBook, and as soon as it's done, there you go. Thing is that I can even screen the output
of my UART cable that's connected to my Ubuntu here. There you go. I can just take this, go to my living room, or wherever it's better for me, and code. Turns out I was being really dumb, because the code is giving me an error, but I've been ignoring that, and just it loads the last file that I created, because I'm not cleaning after my executions, so there's like last files from last time I compiled it, and I just like stopped it from printing anything, and it's still printing H, and I realized that, oh shit. Sometimes you waste days on mistakes like that. Days. It's been like literally 2 days that I have spent on a tiny mistake because of my ignorance. I'm just not reading that. It says 1 error. I finally did it. What time is it? Almost midnight. And that hello is coming from our processor there through UART. It's not just an ordinary hello word. So now that we have our debug UART module in place, we have everything in place, the next step would be to code the memory or the RAM that we have using this flash memory over here. It's going to be 270 kilobytes per second. That's it for this video. And from tomorrow, we're going to try and code the flash memory so that the UART module can actually debug things from the memory. So anything you put in this specific spot in the memory is going to be printed out, just like Linux, just like Ubuntu. So yeah.